Good evening, everybody, and welcome to .NET DC's March event for 2022. I'm Sean Colleen, the host today of .NET DC, joined by Santosh Hari. Am I getting that name? Am I getting the pronunciation correct? I want to make sure I got it right. Okay, excellent. So really happy to be here this evening with you, and happy to kick off .NET DC again for the first time in 2022. We've got a great talk for you tonight, but we want to reach out to everyone out there on stream and find out how you're doing. So feel free to drop some comments or questions in the chat screens where you are. Just a reminder, this event is being live streamed on Twitch, on YouTube, and on LinkedIn events. So we should hopefully be getting the comments and questions coming through from all of those channels. And it's great, I see some comments coming in now saying hello. So hello to you, Asan. Very happy to have everybody here. So I know the talk isn't scheduled to start till 6:30, and we typically reserve the first few minutes here for some banter. And so I figured we're in this remote environment. It's a little more difficult than having even just a Zoom meeting where we're all available. And so figured, why don't we start with a little bit of icebreakers or some things like that. So what we're trying to do today is we've got some polls here for you up on the screen, and we figured you could participate this way. So the way to do that is to go ahead and go to pollev.com/SeanK341. Again, so that's pollev.com/SeanK431. It's at the top of the screen there as well. And we'll put that here on the bottom here, so it's a little bit bigger text-wise. And we'll run a couple of live polls, and we'll see what our options are. So, Santosh, I'm going to ask you what libraries come to mind for you when you think of favorite non-Microsoft libraries and tools, maybe community libraries or libraries and tools from other organizations. Oh, I'll put the link in the chat as well. Thanks, everybody. Yep. pollev.com/SeanK431. Absolutely. Node.js, phenomenal contender. Revolutionary, truly. Oh, it's funny. I posted. Oh, I think I did post the comment or the link in the chat, so we should be good to go there. Okay. Left pad, very nice. Let's see, we've got no shortage of humor out there this evening. That's good. Exactly what I would expect from .NET DC. And Santosh, what comes to mind for you when you think of these libraries and tools that are your favorites or that come to mind for you? What are some that tend to be top of mind for you?
Yeah, left pad was my contribution. So,
okay, so we're off to a great start here.
Yeah. So, no, I think Node is linked pad. I've definitely heard good things about linked pad. The part I'm struggling with is you ask non-Microsoft libraries and tools. Like, what do I use? I guess. What would be a good tool that I use? So, I used to do quite a bit of work with GIS, like geographical information systems. So, they used to have different libraries and tools out in the market, and some of those were open source. Postgres it's not really a tool; it's a database, but it was fantastic for handling geographical data. And they also had Arc. I think Esri it's not really a Microsoft tool. It's also not really open source, but it's been great for geographical data. So those are a couple of things that come to mind. Oh, that someone said Postgres over there, so that's cool.
That's great. Yeah, that was me. I was copying down. I wanted to make sure I was taking it down as you were saying it.
So
a couple of votes there for LinkPad.
The other one I see on here that is fantastic is obviously Markdown, because that's pretty much the writing tool of choice these days for people who are in the programming business. But also Mermaid. Mermaid is fantastic. Have you used that to do?
I have.
Yeah,
It's been really it's especially now that GitHub supports it within the Markdown syntax. It is really something. In fact, I was on a client project these days, and they had an environment diagram that they wanted to create, but the problem was folks were passing it back and forth, and it was in a Visio file at that point. It was just a little bit harder for folks to collaborate on it, and so I was able to construct the environment diagram live for folks in the Mermaid live tool online, and then we were able to put that in a Markdown file, and now we've got it in our version control. And so I'll put that link in the chat for live Mermaid diagram construction.
I know that for the longest time you couldn't use Mermaid with GitHub, but recently they fixed that. They fixed that glitch, so you can now use Mermaid in GitHub. Because
yeah, and it's really lovely that it renders the image right there for you, and you can flip back and forth from the preview. I mean, it creates a lovely experience for diagrams for sure.
Exactly. I don't have to sit around and drag and drop. I can actually just write code and that gets converted to a diagram, which is fantastic, which is the way I like it.
Absolutely. And I see the I saw Hangfire in there as well show up. Hangfire is one of those tools that I absolutely, every time I remember that it exists, I say, oh, what a great tool, and it's like between projects, sometimes it'll fall off my radar, and then I rediscover it and I think, oh, what a phenomenal tool for being able to, for scheduling and background tasks and so forth. Works really well. And I had to give a shout out, of course, to Akka.net because for an actor model system and distributed programming and things like that, really a phenomenal tool. And I said specifically, by the way, I said non-Microsoft libraries and tools, mostly because I feel like Microsoft has a little bit of a leg up there in terms of familiarity with their tools and platforms. And so, I want to make sure that we give a shout out to some of these other tools as well. Which reminds me, today I was actually working with DBUp, a tool that helps you do migrations that isn't Entity Framework, but that does sort of a ordered SQL script running, and that's a really phenomenal tool as well. So definitely feel free to keep bringing those here. I'd be interested. I haven't heard of CLI wrap, and I perhaps should have. That sounds like it would be right up my alley for something to know. So I'm going to take a note to look at CLI wrap as well. I see a lot of the testing libraries on there. We've got XUnit and NUnit and Mock for the mocking library and SpecFlow, all phenomenal tools and resources as well.
So there's also Twilio and its set of tools for sending text messages, and what was the emailing SendGrid. So didn't they buy that recently? So those are some fantastic messaging backbones that you can use with APIs and SDKs.
Absolutely. And I'm curious, we'll take this poll here. I'm gonna stop presenting that here. I'm gonna activate one more poll because I'm curious for where folks are joining us from tonight. And so, I'm going to go ahead and activate that poll. Where are you viewing from this evening? All over the world, we're virtual. We can probably be in a lot of different places. And as someone from the DC metro area, we have a lot of folks from all over the world here, and I love that. And so I'm just curious as to where you are currently viewing us from. And I know the map's a little small. I'm going to do my best to see if we can. Let's see. Niels, yes, we know you didn't bring up Twilio. No worries. It's good. It's a great enough company that people bring it up all their own. I know plenty of lovely people who work there, but it's certainly it doesn't hurt to have you here in the chat. That's for sure. So if you're looking for information on Twilio, I'm pointing you to Niels here in GitHub. So he promised that he didn't bring up Twilio, but we'll acknowledge that he did not bring up Twilio. Great. So I see some folks along the northeast of the U.S. there. Of course, we've got Santoshan in Florida. Excellent. Europe. We have some Europe folks here. Fantastic. And this is where my geography is truly terrible, because I don't know if you've seen, Santosh, there's that, we heard the Wordle game was phenomenal and very successful, of course, but they had a Wordle, which was someone had come up with, was like a geographic take on Wordle, and I have to tell you, stereotypically perhaps for this country, I was terrible at the geography piece of it. And so I'm grateful that everyone's joining from where they are, and I promise to go and make sure that I can absolutely pinpoint everywhere on the map that you're coming from. All right. Well, I'll tell you what, I guess we're getting on in the time here. And so what I want to do today, we'll do a quick presentation about where we are, where we're going, and then we'll introduce Santosh, and we'll get started with the talk for the evening. So just a reminder that once again there are chat in the YouTube and Twitch and LinkedIn events there. So feel free to add your chat or your comments here, and we should see them show up in our chat box here in our aggregate chat box. And so if you've got a question, right, well, I'll be sure to keep an eye out for them and bring those up to Santosh as he's presenting. Or if you just want to join in with everyone else that's participating, feel free. It's a wonderful community here, so we're happy to have you all. All right, so I'll go ahead and throw up the slides for this month here. All right, let me go ahead and take some of these items off. I'm still getting used to StreamYard, which we're using to stream this event. So if you see some things turn on and turn off, don't mind me too much. But okay, so we do have the March 2022 meeting today. And so first, a shout out to our sponsors. I mean, you can see the shirt and the logo there, but Excella does sponsor this meetup both with time for the organizers. When we are in person, they are willing to provide a location. They also provide food and beverages for the events when they're in person. So a big thanks to Excella for sponsoring the .NET DC meetup, as they have for some time. We also have a sponsor in Manning. Manning sponsors the .NET DC meetup by providing a 30% off code to all .NET DC members. So again, that's a code UG367. And so if you were to purchase a book on Manning and you want 30% off, use that code UG367 and we'll be sure to get you a 30% discount. Of course, we also would be remiss if we didn't give a shout out to the .NET Foundation. The .NET Foundation virtual user group is how some of you, in fact, maybe many of you, found this user event today. And so the .NET Foundation itself is dedicated to promoting a vibrant and healthy .NET ecosystem, especially around open source endeavors and the health and stability of .NET itself. And so feel free to check them out at .NETFoundation.org. They're always looking for volunteers. I'm happily a member of the maintainers working group, though I've missed the last couple of meetings, tisk on me. But there are a number of committees that you can get involved in, or even if you just want to join the foundation and show your support, it's a great place to find like-minded folks in the community and help try to move things forward. And so I mentioned the .NET Foundation virtual user group. So you can find them at meetup.com/.net-virtual-user group, or you can go ahead and Google it or Bing it, whatever your choice is. And so that's one of the ways to find many of the different meetups happening around the country, around the world, and to see folks in action. So we submitted our meetup tonight to that group, and they're happy to promote and broadcast. So if you're looking for a variety of .NET user group content, that's a great place to find it. Definitely check it out. And so from here, we'll go for announcements. If you've got announcements, I'll go ahead and say, let's throw them in the chat. Sometimes this is typically where we'd raise our hands in a room, but we don't have a room currently. So feel free to, if you've got a coming event or if you're hiring or looking, feel free to add some links or some announcements in the chat. And then while we're doing that, while folks are taking the time to add some of those items in the chat, I will mention that we actually just scheduled the .NET DC April event, which is great. We've got Kevin Jones, who's currently working in security at GitHub, coming to talk about everything, perhaps too much, about stack alloc. And so learning a little bit about the stack alloc command and memory management and what are some pitfalls and do's and don'ts and how folks like us might find that useful. So definitely feel free to check that out. We just announced it on our Meetup channel, so that's a coming event for us. I also saw that Tech Bash, which is a conference that near and dear to my heart, just announced its call for speakers. So that conference will be in November this year, and that happens at the Kalahari Resort, which is in the Poconos in Pennsylvania. So I'm from the Philadelphia suburbs myself, and so love being able to travel back to Pennsylvania whenever I can. So definitely check that event as well. So with that in mind, I'll keep some things. I'll keep looking for some comments to show up in the chat, and they're a little bit delayed. So my apologies if you don't see me respond to them immediately. But while we're doing that, we also I wanted to point out some online governance tooling that we have here. And so the way we run .NET DC, or the way we're attempting to run .NET DC these days, is actually via GitHub. So I'm going to pull up a web page now, and then I will share my screen. Thought that I had it up already. Okay, so I'm going to go ahead and share my screen there. Okay, so what you can see here is the .NET DC GitHub page. Again, that's going to be at github.com/.NET-DC. And the way it works is we've got an open governance repo where we are currently attempting to find our speakers for our meetup. So if you head here, we have all sorts of information on how you can submit a proposal for a talk, or say if you want to speak but you don't have a date in mind or you're not sure about a topic, there are ways to raise your hands. And the way that we're doing that is we have a GitHub issue for every meeting for the year. Notice how many meetings are still tagged need speaker. So if you're interested in speaking, please do reach out, and we're working to contact some folks and get some great content lined up for you. But if you've got something you want to present, please reach out and don't be shy. But we also have here GitHub discussions. And the way we're currently using GitHub discussions is we have some categories over here. We have speaker volunteers. If you'd like to speak, feel free to start a discussion and add your information here so that we can follow up with you. We've also got topic ideas and requests. So if you're interested in certain topics or certain things we'd like to hear from, feel free to upvote the topics that are here and to start a new discussion and add a topic if you hadn't seen it before. And that will go ahead and look at those and make sure that we'll try to give the community what you're looking for. So if there's a certain topic or theme that we see emerge, we'll make sure that we source a speaker who is relevant and engaging on those topics. So we want you to be the driver of the meetup content and what you want to see, and make sure that we're delivering what you're looking for. So, all right, I don't see any comments with any announcements, and so with that, I'm going to go ahead and jump back to my slides here and introduce Santosh. So he is currently at Microsoft, where he is a senior cloud and AI consultant. He is also the organizer of the Orlando.NET user group and the Orlando Code Camp. It's Code Camp, right? The Orlando Code Camp. Yep. Which is a phenomenal program. And I was fortunate enough to speak at the Orlando.NET user group. They're a great group of folks, and so definitely check them out as well, especially if you see them around on the virtual meetup circuit. Before joining Microsoft, Santosh was a multi-year Microsoft MVP. He's got a background in Azure, DevOps, little of this, little of that. He's been all over, and so we're really excited to have him here with us tonight to talk to you about event sourcing and e-commerce and how those things are intertwined. So with that, I'm going to go ahead and say, Santosh, I'll remove these slides here, and let's go ahead and take it away.
Thank you, Sean. Thank you. So hello, everyone, and let me throw up my slides. Thanks for bearing with me because I'm getting back into the flow of presenting. I have not been doing that for a while, thanks to the Panera, I guess.
And you may need to share your screen as well. Okay, I just saw it come up here. So there we go.
Okay, cool. You can see my screen. Awesome. So welcome, everyone. Thanks for taking this time on a Tuesday evening to offer all things coming to see me speak. Really honored. Hope to give you some ideas. I think that's the whole point of my talk. So before that, I'll just go through. Okay, so if you need to get in touch with me, you can contact me on LinkedIn or Twitter. And I'm most active on Twitter. LinkedIn, it's often overrun by people who are very transactional in their behavior, so I don't check it as often. So a little bit about myself, like Sean pretty much said everything that I do on a day job, or even away from my day job, which is I like to run user communities, speak at them, and that's kind of why I'm doing this, is because I have a passion for sharing what I learned. So my whole goal today is to share the I guess the machinations behind e-commerce systems. So I have been talking about different things like event sourcing, event-driven architecture, Cosmos DB, serverless. I've been speaking about all of this, but lately I have had the pleasure of working on these things, which is working on real life projects that actually help me pay my mortgage. So one thing I discovered while working on these projects is that a lot of the things that I was talking about, these can actually tie together beautifully to build the e-commerce systems that you often see these days that power websites that you're familiar with. So, for instance, like, and this is public knowledge, so I'm not really revealing anything secret, but there's a whole bunch of architectures out there that Walmart has put out. So if you look at the talk I'm giving, this is actually loosely based on some of those concepts. But I've seen these concepts repeated time across various clients. So I'm hoping that with this particular talk, I can try to bring together some of these concepts from a more practical perspective. It's always good to talk hypotheticals, but what does you take event sourcing, you take serverless, or you have a whole bunch of other concepts, but how do these work in real life, and why? More importantly, why? So that's what I hope to talk about today. And so that's what I'll be. It's a very simple talk. So I'll be talking about particular set of e-commerce systems, what it's doing, like a particular component of an e-commerce system, what it's doing, some problems it faces. In the second part, I'll talk about some modern principles like event sourcing, serverless, change, data capture, etc., that help you alleviate this. I will show you a basic event sourcing implementation in Azure, and then, time permitting, we can have a in-depth discussion on event sourcing, or we can talk about anything, right? Please feel free to put questions in the chat, or you can even just feel free to interrupt. I don't mind. I like to have a nice conversation. So with that, we'll drive into e-commerce system. So what is e-commerce, right? So you often, I bet most people browse online. So when you browse online, these are the type of things you come across. So I'm taking an example of a typical shopping cart. This type of website has been around for over 2 decades, right? And it pretty much looks similar, whether you go to Best Buy or Amazon or whatever it is, the electronics page kind of looks similar. So customers browse the website for electronics, they filter by laptops, and then they land on a page that somewhat looks like this. Now, this page sometimes shows some recommendations. Now, obviously, these recommendations can be powered by various things like your browsing history, or for instance, if you're looking at something on if you're searching for a laptop on Google, you log into Amazon, you see that uh, the same laptop pops up as a recommendation, or vice versa. They tend to share your information, so your information is pretty much all over the internet. Not a shock, but anyway, you see things like these, that this is your expert pick, this is what is recommended for you, and so on. So these type of systems. So the next step over here is someone would click add on cart, add to cart, and then from there they would check out, right? So nothing earth shaking. So this is where it starts to get interesting. So right now it's showing me the inventory. Okay, so then I click add to cart, and then I check out, right? So at that point I need to know that when I'm checking out that this item is actually available. I have a few caveats. When I'm browsing these pages or when I'm checking out, it cannot pages cannot take too long to load. Because let's say this is a website, uh, the xyz.com. If it's taking too long, the competitor websites are just a tab away. So this is something that e-commerce companies are really mindful about. So the type of SLAs that they put in place, or service level availability or service level objectives, there are a whole different set of terms in DevOps. But let's just stay at the simple concept of a SLA, or service level agreement. Sorry, and what they're saying is that this website will have 99.98% uptime, and if you are keeping tabs, you can only be down 2 hours per year. So that's kind of steep, and with all the CI/CD stuff going on, that's a challenge, right? Like you could even have outages at various levels. Like your cloud provider could have issues, right? So you got to keep it up for two hours. You can only be down for 2 hours per year. So that's pretty steep. And then what they're saying is that any operation on this page, like I click on something, you know, the I guess the average latency should be 300 milliseconds. So okay, so that's kind of steep, right? I mean, that's 3/10 of a second if you're keeping track. So I will kind of dig into this, and we'll talk about what happens when a customer wants to actually check out of this website, buy a laptop, and then go through the checkout operation. So the general process here is that the customer adds the laptop to the cart, and then when ready, the customer checks out online. And they set the delivery address, and they pay for the laptop. Now, most e-commerce systems, they really don't reserve a product for you until you are in the checkout page, right? So they may show that it is available, but sometimes you go to the checkout page and it says, oops, too late, it's gone. Sometimes even after you hit pay, and this is extremely rare, but you may see that it's not available, or they may come back and say it's not available, or we had issues, right? So that can happen too, but that's very rare. The most common thing is seen as sometimes you're browsing, you're on it for a couple of hours, you kept the page up for a couple of hours, and then you went to checkout, and then it says it's not available. So that's the functionality that we will be looking at today. How does that happen, right? E-commerce is huge. Like I can talk about everyone's favorite topic, supply chain. We will actually touch on that a little bit today, but not so much. We can talk about payments, we can talk about profile maintenance, caching, and so on. But I want to just stay on whether the inventory is available or not. Before I do that, what I want to do is touch on a reference e-commerce system. So if you're familiar with Microsoft Docs, this is a pretty common reference architecture that you will see, which is the eShop on containers. This is a reference application for microservices, and it's a great one. Actually, I learned a lot from this one. So, and people, when they start to build e-commerce websites, they'll often refer to this one because everything is pretty much provided in this. And I will provide the links to these. I'll post the links at the end of the talk. So looking at this one, right? It has an identity service, catalog, ordering, basket, and other microservices. And what I have learned from experience that this is a really good architecture for small to medium-sized businesses. But when it comes to larger e-commerce operations, That's where it starts to get complicated. And that's nothing to say about this particular architecture, but the real life e-commerce system are far more complicated than what you see on here. It can get really gnarly, so if you're not careful. So for instance, I'm highlighting the ordering microservice on here. So we'll kind of drill into that, right? So this is your e-commerce website. Excuse me. So this here, in this example, this is a real life version of the ordering microservice. Uh, you have an e-commerce website that calls the microservice at the moment you're about to place an order. So, but we say this is a microservice, but for most e-commerce companies, this is actually an entire organization. It's not just like one service sitting out there. This can be entire team. It can be an entire org. So when the e-commerce website invokes the API, it'll invoke a single API. Let's say it has to check with all these other items. So it has to check the warehouse inventory. It has to check existing orders and reservations. Sean, thanks for posting that link, by the way. Now, it has to check the store inventory. So, you could be like a big box store that has an e-commerce website. So you may have inventory both in your warehouse and your store. And in the store, it could be on the floor, or it could be in the back room, or it could be in the returns area. So there's a whole set of things you got to check. And then you got to check sales caps, which is, for instance, if you are familiar with Xbox, like they may have a seasonal limit. Some stores may have a seasonal limit for Xboxes. You have to check third-party inventory, like partners and suppliers. Sales caps, we talked about that. And finally, you may also have to check legacy systems. If you look at a lot of these warehouse, third parties and others, they may be using some kind of legacy systems behind the scenes that may or may not have duplicate inventory. So with that, what does this architecture look like in real life? So what started out as a simple service actually starts to represent something like this. So in here, each component is actually represented by a box. And like I said, each box could be its own team, or it could be an entire organizations, like you could have a warehouse organization. And each has its own set of service, or more likely multiple services and multiple databases that it has to check every time you place an order. So what happens when the customer wants to place an order for a laptop? It kind of starts to look like this in real time. So let's start here. So So you have the website. The website places an order to it places a call to the ordering API, which goes to the warehouse to check if it has the item in stock. If it found it, great. If it didn't find it, it goes back. Oh, I didn't find it at the warehouse. I'm going to go check the stores. So I go and check the stores, but the stores may have reservations, they may have back orders, they may also have things like returns. So you got to check for all of that. And so let's say it found this item at the store. It still has to go and check the third parties to make sure there are no duplicates at any third parties or anything like that. In that case, they have to eliminate the duplicates and so on. And the third parties may have legacy systems. And once it checks all of this, it still has to go back and it has to check against the sales cap, for instance, for that particular item. So the item may be in low supply. So they may say we are only releasing 1,000 units, and if this is the 1100th order, chances are it's not going to work. So as you can see, when it's all said and done, we have to check to make sure we have to make multiple calls, including a ton of synchronous API calls until we can finally compute the answer. So what's the problem with these calls? Yes, definitely. So some of the ugly happenings behind the scene, Niels. Yes. So, what are some of the problems that this poses, right? So let's say the overall system has to fulfill a 99.98% uptime with 300 millisecond response, right? So what you're essentially saying is that it has to place, correct, exactly. It can, each of these individual services has to respond in such a manner that all these calls combined take less than 300 milliseconds. So just start to think about that, right? So you're talking about like 20 to 50 millisecond latency for each of these individual components. You have to fulfill that condition. And not only that, if my system is only as reliable as the weakest component, right? So if I'm saying I'm providing a 99.98% uptime, which means only 2 hours per year I'm allowed to be down, I have to make sure that all of these components exceed that particular level of SLA. So they are going into 4 or even in some cases 5 nines of uptime. Now, if you know anything about SLAs, I had a good friend who used to say that every 9 you add to your SLA, you basically raise the cost by 10 times. So 99% is something, 99.9%, it's probably 10x that, maybe not these days. But when you start to get into 4 nines and 5 nines, you are talking about 10x, 10x. So the costs start to go up exponentially. So the other issue you face with this is, for every single call, each of these services have to work correctly. They have to deliver on the spot. So even if one service goes down, you risk giving the wrong answer to the customer. And one thing they say in e-commerce is better not to give an answer at all than to give the wrong answer. Excuse me. So in summation, one service can take down the system, or each service is a single point of failure. The next issue, how do you test these? So sure, I can write individual unit tests to test like each individual service, but to see if they all work together, that's a nightmare. I mean, how am I going to test that? These integration tests are hard to execute, complicated complicated to set up, and expensive in terms of computation. And you got to make sure that you basically have to replicate your production environment and have the same levels of performance to test these. So it's expensive. And not only that, you see all these red lines, right? And the red lines, red arrows, show real-time API calls. So you have to test the entire dependency tree. That's crazy. And the main issue with these systems is state. So each of these services or systems was designed in a traditional manner, like kind of like the service-oriented architecture. Even though you see microservices, if you string together a series of synchronous API calls, you're actually in service-oriented architecture. Now that may be a controversial statement, And feel free to come off mute and yell at me, but I believe it's still service-oriented architecture. And you know, not only that, they were designed as in a traditional manner. And one of the things that happens is, let's say you have a component like reservations, right? So if this changes, it stores the state locally, right? So it mutates its state in place. Now, what we are assuming is that every time you make a call, that there are no outages and everything stays up all the time. Now, anyone familiar with any kind of distributed systems knows that failure is just around the corner. So you have to generally account for the fact that your system will fail. So what we have in here is code that is distributed, unreliable, and expensive to uh, execute. Also, think about this. What happens when a component goes down or a bug is introduced? Or let's say you're in the middle of a process or a call and something fails. Like, how do you go back and redo things? So, all of these are extremely hard to navigate. And to put it bluntly, this nothing is reliable in distributed systems, and we have to account for downtime. And storing state locally is not is frankly, it's like the worst idea in this case. Again, I'm making a lot of strong opinions here, but I'm a consultant. I get to do that. Feel free to yell at me during or after the talk, or you can yell at me in chat. I'm reading the chat as I speak. So I want to introduce some modern principles that help alleviate this. So the first is the number one thing we like to do is switch from synchronous API calls to message and log-based communication. Why do we do that? So in this case, systems communicate with each other or using messages, using queues, or log-based pub subsystems like event hubs and Kafka. So what happens in these systems is you can see that there are a whole set of events that come in, and they have all these protocols and that work, but they come into these event hubs or Kafka, whatever you have for storing messages, and these messages are stored in order that they came in. So let's say you have a series of events, these messages come in order, and not only that, they are retained in these services for later consumptions. So, and how do they do this? They use a technique called checkpoints. So let's say one of these consumers was pulling something from this partition and the consumer went down. The next time the consumer comes up, this partition event hubs actually keeps a checkpoint saying that this consumer was talking to this partition and it was on the fourth element, and so they can go back and pick up from the fourth element and just move forward. Additionally, you can also go and replay events as if they like you're replaying a movie or something like that. So if you have an outage, or you can reset the checkpoint to the point in time before the issue. This makes it really easy. So if you have outages, it makes it the mean time to recovery. So if you're familiar with DevOps, they talk about mean time to recovery. It solves the problem really well. But for that, you have to be prepared to replace a lot of your API-based messaging, API-based calls with a message and log-based communication using Event Hub and Kafka. So event sourcing. So this is kind of everything starts to come together around event sourcing. And why is that? Events are facts about something that happened in the real world. Uh, so when an event takes place, for instance, let's say look at it in here, right? So if you say item one was added, you can look at it 2 months down the line, and this would still be true that item one was added back on such and such date at such and such time. So it's a fact. So events are basically first class citizens in the system. The data source, the event store, as you call it, is an ordered set of events. And the current state is if you go back and replay every event that ever came into this system, you can get to the current state, so that it doesn't matter if your system went down. You can simply go and replay everything and get to the current state. A good example of this is even outside of e-commerce. Think about bank accounts, right? Banks are really good about this. They know every deposit, every withdrawal you ever did. So even if you are occasionally overdrawn or something, they will make sure that it's accurately reflected, and you can go back and look at every transaction you ever made and get to the current state. Excuse me. So this is kind of a time machine. You can not only get to the current state by replaying the events, but you can go back and see the state of the system at any point in time, and you can walk through each state step by step. So what problem does this solve? It's easy to replicate the state of your system at any point in time. And it's also good for debugging and analytics. So the next concept I want to talk about is stateless computation. And I'll say that it's not necessary that you have to use any kind of either Azure functions or Lambda, AWS Lambda or Google functions for this, but they, by their very nature, work really well in this type of scenario. And this is why. Basically, in these type of systems, you want to make sure that all your business logic is stateless functions with zero external dependencies. You're collecting all the state you need, and you're passing it into the code as parameters. The function itself is predictable and atomic in nature. And it's also idempotent. So if you pass the same value, it'll always give the same result. Yes, please. Feel free to submit comments. I'm happy to take questions because I can certainly use a break. I'm not used to speaking for long periods of time, so this is interesting. All right. So back to the functions. The functions, the predictable atomic in nature. There are no random outcomes or partial results. So if you run the function, you either get a proper response or you get an error message, both of which you can handle. Real world failures may, for instance, your infrastructure could go down, you may lose network connectivity. They will keep your code from running, but they will not cause an uncertain state. And the domain logic in this type of system is easy to test. You can test a wide set of scenarios. It's stateless, so it makes it really easy to test. And more importantly, the integration tests are basically strictly connectivity, right? Because each one is atomic. So all you need to do is make sure that this one is able to connect to this one and pass a message. That's your integration test. You must also consider a service like the Azure function, AWS Lambda, or whatever it is, to run these stateless computation, because they are the operations are atomic, they're extremely scalable. So for instance, in this example, I have, it connects to all of these services that you can see on the left. If you drop like a million messages into Event Hub, it has a scale controller that actually goes to the function host and say, by the way, I'm sensing a million messages, please scale out. So it's going to create multiple instances that can handle these million messages. So you are really not having to deal with any kind of scaling code or anything of that sort. And more importantly, the integration. So for instance, you can see that it's able to integrate with all of these services. The integration code is largely abstracted away, as you'll see in some of my code samples later on. So you're getting some state values, and so in the messages will be some state values, and the state values get passed into the function, which has a set of code, and it's stateless. So and that's another good reason functions kind of force you to use a stateless computation type scenario. You don't want to be introducing state into functions. It's not easy to do that anyway. So you're kind of forced to stay stateless, which is really good. So you get you get the stateful values in your messages. You pass them into the function. It'll run its calculation and provide some results. And you pass the same value over and over. It'll provide the same result. So the next concept I want to talk about is dual writes. And as a .NET developer, I have done this a million times in my career, which is basically I will take a record, I'll write it to the database, and then my code will write an entry to the log or something of that sort. So once the business logic is complete, it tries to provide some kind of notification saying that it performed a write. So this is kind of not recommended in e-commerce systems, because let's say you write to a database and then you turn around and you try to notify downstream customers. And there's an outage. We are always worried about that in distributed systems. You can never count on things being up. So if you have an outage, what happens? And do they not get notified? Are you going to redo your write? How does this handle that? So that is one of the core concepts of dealing with e-commerce system is don't use dual writes. You have to use write once to the source of truth, and then you use a technique called or a framework called change data capture. So dual write exposes you to failure and it exposes you to an inconsistent state. But the change data capture, what it does is it is a framework which actually enables you to write and notify on the same thread. So that is really powerful. So change data capture, it'll publish the event or it will publish a notification only after the commit event is done, and it does all of that, and it handles it. It makes sure that the change event is published to an outgoing queue, which makes it very resilient. So even if there's an outage, someone can go and check that queue after the outage, and they'll be able to get the event. So you will never lose an event using change data capture. Now, change data capture, so a few databases in the cloud handle this very well. You have Cosmos DB, which has something called a change feed that is built exactly for this purpose. So once you write, the change feed actually, any changes to data is captured in the change feed. So you can go back, and if you have something looking at that, and that particular consumer goes down, when it comes back up, it can go and look at the change feed and pick up and continue. So again, you're basically programming for failure. uh, I think AWS has a Kinesis. I'm not sure. I'm not an AWS expert, so please don't quote me on that. Any questions? I don't see any. Cool. So this must be good.
None so far. You're doing great.
Awesome. Thank you. All right. So, and one of the other concepts I want to talk about is replacing real-time computations with data lookup. And this is it's hard to convince people who have worked in the traditional format to go with this. But what, what this is, let's say I want to find the shipping options to my house, right? So my house is located in a particular zip code, and you have shipping companies, USPS, UPS, FedEx, and so on, and they have 10 different options, and then they may have different set of criteria for shipping to my house, right? But what we know is that if you take all the zip codes across the US, there are, I don't know, I know there are 3,000 counties, so maybe 300, I don't know, there's like 30,000 zip codes or something, maybe less than that. So maybe someone can look that up and post it in chat. So uh, what I'm saying is that instead of providing your zip code as an input to a service that will then go and do the computations to look up shipping options. In modern, there are 41,683 zip codes. Thanks, Trent. That's perfect. Thanks for that answer. So, what I'll do is I will take I'll take all the 683 zip codes. I will take all the providers. So let's say we have 3 major providers. Let's say 5 just for giggles, right? And these providers may have 10 shipping options each. So we have about 50 options. So I'll take the 41,683 zip codes times 50 shipping options, and I will put all of these in a lookup table, and I will tell as a key value pair. So next time I come in and show me the shipping options, all you're doing is show me the shipping options, and let's say I have 3 shipping options. It's a simple lookup instead of having to go in and run computations. So for items that I can pre-compute, I will pre-compute and store that in a key value pair. So it's or some sort of cache that's easy and faster lookup. So the possible set of inputs, all the possible combinations. So we are substituting real-time computation for a pre-computed cache of results, because real-time is expensive and prone to failure. So that is one way of replacing real-time computations with data lookups. A more advanced way of doing this is what you're seeing on the screen. It's called Lambda architecture. So in Lambda architecture, there's a few things going on. You have a set of data sources. All the data comes in, and all the raw data comes in, and it gets stored in the red-looking box, which is like the primary data source. But when the data source is coming in, I can also split it into windows and send it to the speed layers. And one of the things I want to do is I want to provide immediate results, right? So for the last hour, I would like to provide a set of sales data or something like that. So that goes into the speed layer. So you don't have to store as much data, and it's fast to look up. So that's a real-time, fast lookup of data. But I'm also at the same time crunching the batch layer, which is the red box, and I'm splitting that into views and storing snapshots. So I'm looking up, snapshots of old data and a streaming instance of the real-time data. So how I would compute uh, the state of the system is, I'll take a previous snapshot, take the real-time data, and that's my current state. And both of these, so what you're doing is you're basically taking your older data and putting that in relatively cold storage, and you're keeping your real-time data or near real-time data in the fast or hot storage. So uh, one of the things that this does require is that you have to embrace this concept called eventual consistency. So your data uh, in the serving layer will become eventually consistent. That is, when no data is coming in, this will be consistent with all the data that ever took place. But until then, you have to make sure you use the speed layer for the latest set of changes. So hopefully this makes sense. I want to, before I dive into this, I've been talking for quite a while. I've been expressing some, you know, controversial opinions. I want to see if there are any questions. Okay, good. Regarding the example of having, doesn't this add overhead of? Okay, so the question is regarding the example of having all the zip codes delivery options, doesn't this add overhead of maintaining that data? Example, all the valid zip codes. That's an excellent question. So I'm glad you brought this up because, yes, it does add the overhead of maintaining data. But let's take a look at this. I have 41,683 zip codes. As far as I know, zip codes are not something that are updated on a daily basis or even a weekly or monthly basis. I may get a new zip codes once in a while, but I'm not sure like if it's an act of Congress or whatever it is, but I don't think they just randomly go about publishing new zip codes. So it is a data source that does not change dynamically. Same for shipping options. So, you have suppliers. Okay, typical for 10 to 20 new zip codes to be created each year. Thank you for that, Sean. So, yeah, so, let's say 10 to 20 new zip codes. So you have 2 zip codes added per month, right? So I can kind of, go and crunch options. And even if the zip codes are added, it takes a while for all the uh, shipping carriers to catch up with those changes. So just keep that in mind. Sometimes these e-commerce systems are way ahead of some of the infrastructure or other infrastructures that they depend on. Okay, so zip codes don't get added too often, and shipping carriers don't change too often. Shipping options don't change too often. So what you have is worst case, like the absolute worst case in this is you have to go in and run that computation once a day. Now, would I trade a once database that I have to maintain on a once a day basis to having to run synchronous API calls in a distributed systems that are prone to failure? You bet I would. Hopefully that answers your question if I understood it correctly. Okay. Okay, so I don't see Any other questions? I hope I answered the other question. So coming back to architecture. So, in the previous example, you saw that you basically were making a bunch of synchronous API calls that are, I guess, in a best case, they're inefficient, right? So let's flip this. So now we're going to switch to an event-driven system. So what we're doing is we are streaming events and messages over Event Hub. So anytime there is a change in any of these systems, it starts streaming messages. So if there is a new reservation, it's going to reach out and it's going to update the warehouse and store data. And the warehouse and store, what they'll do is they'll send their data further down the line, and they will actually go into a source of truth database for the ordering microservice. So similarly, if there is a back order, it goes and updates this. So what we are doing is we are asynchronously sending data updates, and we are streaming those data updates to a source of truth database that our ordering API is going to look up. So legacy systems, these don't change often. So they're going to deposit all the data over here, and the third parties then do their work and they send their whatever findings they have to the order data service. If I have a sales gap, I'm going to directly publish it here. So what's going to happen is the source systems push the data changes. So we are kind of switching from a service-driven architecture to event-driven architecture. All the components are asynchronous. The messages are flowing from left to right, at least on my screen. And we are trading real-time computations for pre-computed data. So, and in this type of system, when I want to do a lookup call, that's it. So instead of doing 10,000 calls and synchronous API calls, what I'm doing is I'm simply streaming all my changes asynchronously to my data source, and every time I want to look up, my API directly looks it up from the data source. So this seems like you're cheating, and in a way you are, but you're basically reducing the amount of, I guess, you're reducing the likelihood of failure, you're reducing everything else. And the other great thing is, let's say one of these system goes down, right? So I may not have a update, but I can actually notify my ordering API and say, hey, by the way, the warehouse system is having some issues. Maybe we can just continue using the data we got from the store system, because that may still be up to date. So I can do all of that type of state maintenance asynchronously, and that reduces the likelihood of failure. It increases the speed at which my service responds. And then keep in mind that I'm making one service call, one database call. And if I had to, set this at a 99.98 with 300 milliseconds, okay, yeah, sure, I can do that. I mean, that's just for one system. So my maintenance cost, the complexity goes way, way, way down in real life. So hopefully, okay, I'm getting a question. You can keep those messages. Exactly. So that's the other thing. So I talked about the message and log-based communication. So you can actually let's say the warehouse service is down. Any reservations that were made here, they get queued up on the warehouse service. And when it comes back up, it simply picks up at the checkpoint and sends the latest updates to the order data store. So that's another way. It's a resilient system. It can absolutely survive all kinds of. By the way, that's Labrina. Hey, Labrina. Uh, and it can absolutely survive any kind of resiliency issues, and it just it's a delight to maintain actually. So I'll pause and take questions before I dive into some the simplistic implementation I have. It's just to prove the concept. Any questions? Anyone wants to yell at me or nothing?
No one's yelled at you quite yet. I have been monitoring the chat, and there's been zero yelling so far. So I
I
think
don't think.
you're okay so far.
Okay, maybe they don't believe me that it's this easy. Okay, good, good. So I have a question. So you have Ticketmaster and you're booking tickets for an event, which will get sold out soon. Asynchronously, how would you ensure that the next customer can still book an event, since one would need to know how many tickets are available? Will the event and time lag based work? So, and Neil says, why is no one yelling in caps? Yes, I am surprised about that. So I'll go back to the Ticketmaster question. So I'm not a country music fan, but my wife is. So I recently had to um, go online to buy a ticket for Garth Brooks who's coming to Orlando. So yeah, that's going to be interesting. Me at a country concert, but okay, we all have different experiences, and I'm sure I'll be live tweeting that. Um, but not to digress. So I had to go online to buy the ticket, and the way that system worked is, well, you had to queue up. So an hour before they opened the ticket sales window, you had to go log in to Ticketmaster and enter a queue, a virtual queue to speak of. So I was given a number like 2000, and I'm sure that the people who queued up after me or before me were probably less than 2000, and after me were like 10,000, 20,000, whatever it is, right? When the window opened, I was told that I was the 2000 something person in line, and I could see that gradually decreasing. So again, that's it's an e-commerce system, but it's also a different type of e-commerce system. I would guess that in this particular instance, I had um, 15-minute window to book my ticket I got uh, once my place in line got to the front. I had a 15-minute window to book the ticket. So it's probably holding the reservation for 15 minutes, which is, uh, in the case of the laptop system, that's more aggressive in that, if I have a laptop in my cart and it's the hottest selling item, it can get sold out. But in, in the case of uh, a stadium ticket, they could put a hold on a certain seat. So they probably did not put a reservation until I picked my seat. Once I picked my seat, they put a 15-minute lock on that, and then I was able to book the ticket. So I would say that in a way, Ticketmaster's system is less aggressive than e-commerce systems because it gives you a 15-minute window. Event-based. So the question is, will an event-based system with time lags still work? Let's see. Why would it not work? The only Maybe someone can help me picture this. Why would it not work? Oh, I may be a little opinionated that it works, but maybe someone can point out a reason. Because it's less aggressive in a Ticketmaster scenario, I think it should work. So
I'm of the mind to agree with you. It seems like I have trouble thinking about what ways it would not work in that scenario.
Yeah, it's almost like, this type of architecture, uh, it's a little hard to believe that it would work that way, but it really does. I mean, as way and again, in fact, I started using event sourcing, and I'm afraid that I may soon resort to building all of my other systems as event source system, which is not a bad thing, but you want to make sure that you're using the right type of architecture for the right type of scenarios. So I do want to be mindful of that. But yeah, it does work fantastic. It does work beautifully, and I have little qualms that, or zero qualms that it would work in the Ticketmaster scenario. So yeah, I'm still wondering why no one is yelling. So with that, what I'll do is I'll pause my presentation.
I've got
Okay,
a question
so
there for myself in the chat, just in case you're interested in taking one more question, but I think you might be getting to it in a little while.
exactly. Thank you. So this is that gives me the right segue. So I will, I guess I'll still share my screen. So I'll get to the next one. So this is an example of the event source system that we saw. So your question was, what tools and libraries are in particular useful when building an event source system? So I can certainly talk about the tools part. I'm sure that you know there are libraries are probably related to these tools. I myself, I don't exactly write the business logic code. I'm more on the infrastructure side, so my knowledge of the libraries for business logic code is, I'm sorry to say, it's a little lacking, but definitely I can talk about the tools part. So this is a I guess an event sourcing architecture. You have a presentation layer, so that's you think of it as a website, mobile app, whatever it is, right? And then you have events generated by that. These events get stored in a source of truth or database that stores the raw data. And then once it stores the data, it publishes the events. The published events can go to either a database or an external system. So how would this look if I implemented this with Azure tools? And I use Azure because that is my bread and butter. So I you could certainly do the same thing with your cloud service provider or even your on-prem whatever databases and um, tools of choice. So with that said, this kind of looks like this. So if you take a look at this, this is an event hub. So that's the one I would put at top, uh, just to make sure that it captures all the incoming events and then it stores them. So Event Hub takes care of that. It captures the incoming events. I can attach consumers to it and consume the events, but it also stores the events for a while, so I can go back and replay it if needed. I need something to a consumer that captures that actually, once the data gets stored in event hubs, I want to pick it up and relay it along. So I use Azure function for this. It drops the raw data into a Cosmos DB database. From there, the Cosmos DB database publishes the change of events. So I'm picking up the events with a Azure function again. And I'm kind of overusing Azure function in this particular scenario. Just to be clear, in real life implementations, I would probably use Azure functions like in one of these, but if I wanted to respond to the business logic and do something heavy with it, then I may use something else, like a Kubernetes service or something that's deployed. Again, it The use cases are wildly vary, so I don't want to be prescriptive here. This is just some of the tools that I can suggest that are really useful. One of the good reasons for using Azure Functions is, you don't have to handle the scale, and also you don't have to handle the plumbing code. So it can directly connect to all these services. So those are some tools. Obviously, you'd need the NuGet package libraries to do this. So with that, I'll stop this and I'll try to walk through an example. So let's see. Are we able to see my screen, or do I need to zoom in further?
I can see your screen, but what I'll do is I'll inlay your picture so the screen's a little larger.
Okay. So I have a few items on here. So let's go to my resource group. Oh, wonderful. So like I said, I have a Cosmos DB resource. I have a Azure function, Azure function resource, and then I have an event hub. So this is the event hub, and this is a very simplistic event hub. So there is not really much to it. What I wanted to show was event hub names. So event hubs are funny. Event hubs, when you create an event hub, you are basically creating a namespace, and then each item under it is called an event hub. So it's really confusing. I think in Kafka, they kind of do a better job of explaining it. You create a Kafka cluster, and then these are Kafka topics. So, that's how I feel like it's better named in that particular scenario. So this is the equivalent of a topic, and this topic can have consumers that are connected to it. So that's very straightforward event. So the next thing I'm doing is I have a function. So I have two different functions. Number one is a event hub trigger. So the reason I like to use functions is let's get into the event hub trigger, right? So what did I do to exactly connect to this event hub? And if this ever finishes loading, I can show you. So I created a binding in my function, incoming binding, and it's connecting to that event hub. So, and this is the connection. It looks this up from the application config, and that's all I need to do to connect my function to the event hub. So that saves me a lot of code, and I don't have to handle error conditions, which is a really great thing, because the less code you write, probably the better in a lot of these distributed scenarios. And then this is a very straightforward event hub. It's reading the incoming message. It's deserializing the object, and then it creates a connection to a Cosmos DB resource, and it's sending that data to Cosmos. The absurd document, basically, it takes the object and it sends it to Cosmos. So again, going back to the diagram, I think, let's see, still have this okay. Going back to the diagram, this is the function. This is my function. It took the events that came from Event Hub and it's sending it to Cosmos. So the step 2 in this is I want to take the, sorry, let me go back to my diagram. So I want to take the events that are published out of Cosmos. So the change data capture that happens in Cosmos, as in once the data is stored, my function, it publishes that. And then I want to capture that and at that point I can do whatever I want with it, right? So it's really not important beyond that stage. I just want to show it's captured. So this is the second function, and that is using a Cosmos trigger. Again, my connection has been made real easy thanks to Azure Functions. I'm using the bindings. I'm saying, it's a type Cosmos trigger, incoming, this is the connection string for Cosmos, and a few items like what database and what collection in Cosmos. Also, you may find something called the lease database. The lease database is the one that does the checkpoint. It maintains the checkpoint. So even if your function goes down, um, I actually had this happen to me last night. I was writing code to kind of prove this out, and I had a bug in the code. It's not important what the bug was. In fact, I don't even remember what the bug is. But for the longest time, it would not read anything from. Actually, it didn't happen here. It happened in the event hub. It would not read any events from the event hub. So I was really confused. What's happening? And then I fixed my bug. My bug was that I did not have the Cosmos binding in here for the output. So that's what my bug was. So my code, Azure portal is not real friendly, so I couldn't quite get to figure out what was happening. But once I fixed it, my the function came back online. It picked up the events that are sitting in the event hub that had accumulated, and just it automatically processed those and forwarded them to Cosmos, which was quite amazing. Like I was like, this is what I'm trying to prove, and that was a really cool experience, like unintentionally. So let's see how this works. Well, before that, I want to go and look at my Cosmos. I'll also show you an interesting tip in Cosmos. So I have data in here, so I want to get rid of this, right? But there's no easy delete command in Cosmos. So I'm going to use this this setting called time to live, and I'm going to change this to a very small number. And once I save this, and it takes effect, it should automatically purge my data. There it is. My data is gone. So, yes, hopefully this tip itself was worth the price of admission. So let's go back. I'll change this, but I do want to keep my data, so I'm going to turn off that setting. So right now, if you look at my Cosmos, it has no data. I'm not sure what's going on. Of course, this will not work during a demo. Okay, we'll come back to this one. So I'm trying to purge data from my Cosmos collection. So while this is happening, I will fire up my Visual Studio IDE. So I have a program, a simple console program in here, .NET. So I have a class with a bunch of enums, and what this class has is it's the inventory class. So it's telling me where the inventory is coming from, what is the count, and then it's telling me the type of inventory. So all of these are I'm just storing as enums. So is it like inventory from warehouse, a store, and the manufacturer, and the type of action. And the type of action is the one I want to demonstrate. Inventory action type. I'm saying ship or stock. So when I say ship, it should subtract, and when I say stock, it should add. So actually, speaking of cool tools, I'm using Bogus. If you have not used this, it's really it's a really cool tool that you can use to generate bogus data. So if you haven't checked this out, I will put a link to this, but it's an open source library. It's maintained by this guy. I actually gave him a shout out. I forgot his name, but thanks to thanks
Bill
for creating this.
Chavez.
Yes, yes, Chavez. Yes, exactly.
I'm sorry, Brian Chavez. Sorry.
Brian Chavez. Yes, yes. So thanks to Brian for creating this, but it's a really awesome library. So you can see that don't do this. I'm using a connection string to connect. There are better ways to do this, but I'm writing a console application, so I can probably do this. So I'm generating 1,000 events at a time. So I'm creating an event hub producer client, and then this is where all the magic happens. So it has a class called faker, and for like each property, it goes and you can uh, just pick from the enum values at random. For the inventory count, I'm just generating a random number. So I would really suggest checking out this book library. And then for each item, it's basically pushing that item as event data and using the producer client. I'm sending that data to to the event hub. So that's all this is, right? So let's see if the demo gods have decided to cooperate and purge my data. So it looks like they did. So I'm going to turn this off and hope that I didn't, the data doesn't come. Oh, I'm not sure why this is doing that. I have never had this happen to me. You know, also don't know if I have a process somewhere that's sending data to this. Okay, so let's forget about this. So a couple of things, right? So when I run this program, what you should be seeing is that data uh, data comes into the event hub, which there is no real good way other than looking at monitoring tools to look at the event hub. But fortunately, I have a event hub trigger, and this actually reads the data and it copies. It puts an output saying that this is the value of the data, and then it copies that to Cosmos, right? So I can actually leave my log window up, and it should provide some useful information, assuming demo gods cooperate with me. And similarly, the Cosmos should trigger every time a data is written to Cosmos. So that should kind of prove my basic scenario, right? So I'm going to fire this up and run. So this is going to create like 1,000 records or something. So let's go back and look at our event hub triggers. So there you go, the event hub trigger is fired up, which means that not only is the data flowing from my not only is my laptop sending data to the event hub, but this trigger is actually reading data from the event hub, and then it should be passing data to Cosmos. As you can see, Cosmos is saying something, right? So add to data, subtract from inventory. So if you go back and look at my code in the Cosmos trigger, uh, so it's reading the data as a read-only list, which is very specific to Azure functions. So for each item on the list, it's reading the properties. And what I'm saying is if the action type is ship, I'm going to subtract from the inventory. If the action type is stock, then I'm going to add to the inventory. And that is basically, if you look at this diagram, it's any action that further happens can be handled further downstream from this function. So that is what I have. I can dive into some basics with event sourcing. I'm not sure about how I'm doing on time, or if I'm more than 1 hour, I would rather stop and take questions and have a lively
Sure. So,
conversation. Yeah.
well, I think one, thank you for sharing for all this information. I know it's not easy on a stream where you're not necessarily in a Zoom meeting and seeing all of the feedback from folks throughout. But I think that the information has been great. The I think in terms of time, we've got about 20 minutes before the end of the event. So I think it's probably been about an hour and 15 so far. So I'd say that's just in terms of your time check. So we can switch to questions, or if you've got a few last tidbits to leave us with, that's fine. Or otherwise, you've been giving us plenty of time so far. So feel free to wrap it up if and when you feel it's appropriate.
Yeah. So I'll wrap it up real quick. So, I just had a few, I didn't want to go through like, add more information on top of this on event sourcing. So I'll upload my slides. So I'll provide the link to my slide. I also have the GitHub repo that I plan to start adding some of these materials as actual text on that instead of a PDF slide. So you can follow that GitHub repo if you want updates. But just wanted to touch base on some considerations for event sourcing. So, some of the things you need to know about event sourcing is that there's a source of truth database, right, for event sourcing. So this database should never be updated by anything else other than the event hub or whatever is sending in data. So that's one of the vital parts of event sourcing. So don't forget some of those basic concepts when you're working with event sourcing. And also, one of the things I always like to do is talk about uh, the cons of event sourcing, right? Like, otherwise I'm just, selling you marketing. I'm just doing marketing if I don't talk about the cons. So, you know, event sourcing is really good for simple domains. So, make sure that the domain size is really small. Uh, and, the non-domain, you have to just make sure that you are being mindful. If you're using domain driven design, just make sure that you're careful about what the bounded context is, and it how to not exceed beyond that and other things. So the other thing with event sourcing is that systems where consistency and it's really bad to use uh, in systems that require real-time updates are where consistency is really important. So event sourcing works really well in eventually consistent systems. So like you know I wouldn't, even though it's really works well in a banking type environment, I would be mindful of using this in that particular environment because it works more on the eventual consistency principle. So even though I gave you an example of a bank and how the account becomes eventually consistent, but I'm not sure that this is the right paradigm for that particular environment. I will tell you which one it is, but I don't know. So I would just be mindful of that. Systems where audit trails, uh, systems where audit trails are not required. So basically, if it's like a simple system where audit trail history, rollback, replays are not required, I would not use event sourcing. It just complicates things, right? And finally, uh, systems where there's, in this particular example that I gave you, it's a high conflict system. Like you could be literally fighting over a single laptop and only one person gets it, right? So if you don't have those type of high conflict systems, which I'm sure that there are plenty of examples, you should probably not use event sourcing. So with that, I'll just stop sharing, and feel free to provide me questions. I will also post a link for the slides, and then we can all, go and be merry.
Great. Hey, thank you so much, Santosh. I know it's difficult in the age of less interactivity to be streaming to a crowd, but without being able to get that interactive feedback, I know as a speaker that's always tough for me. So want to thank you again for coming out and giving us this great download of information and kicking off the season. And for those of you who are looking for Santosh, it's is it _S_Hari? Is it the
Yeah, it's a very inventive Twitter handle, but actually probably the suckiest Twitter handle, but it works.
No, not at all. So I just wanted to make sure I added that banner there. We'll make sure so if you're looking for Santosh, that's a way to find him. And certainly we've got the links in the broadcast so far. And so next up, like I said, for .NET DC is we're looking to April, right? We're looking ahead to our April event, and we're going to be talking about security, or we're going to be talking about Stack Outlook rather, with Kevin Jones. And if you've got ideas for a topic, post them again in the open governance group that we mentioned earlier in the session. And if you want to speak, definitely feel free at any time to reach out to me, especially if you're a new speaker, you've got a topic you've been trying to put out there for a little while. We want to welcome everybody to the group. So if you've got anything to share, we'd love to have you. So feel free to reach out. And with that, I will say thank you so much to Santosh for making the time and speaking with us. And really, really hope to see you around the group in the future.
Yeah, thanks, man. And hope to see you all. If you ever see me at a conference or something, just feel free to come yell at me saying that I'm wrong.
Great. Well, thank you so much for everybody, and we'll see you around soon. And with that, be well, do great tech, and be good to each other. And we'll see you soon. And thank you, and good night.
Right.